We're starting? Okay. Okay. Hello everybody. I'm Nicolas Saint-Lé. I'm developer at Odoo. I've been working for 5 days as a technical consultant at Odoo, and now I'm part of the internal team. The internal team is in charge of deploying the odoo.com and all the instances you can create on Odoo. That's what the team I'm part of is doing. Here you have a pad where you can write down your questions, and I will answer the questions at the end of the talk. I will try to stick to a 40 minutes talk and 10 minutes question and answers. That's the schedule. I'm here to talk about the performance and how to achieve performance by deploying Odoo correctly on your own servers. So I will not talk about the Odoo SaaS nor Odoo SH because it's done for you. So we assume that you will deploy Odoo on your own infrastructure. This is the way Odoo is built. Odoo is built with mainly 3 layers. You have the layers that the end user have on his own laptop. It's built with the front-end pages, the CSS, the JavaScript, and so on. Besides that, you have the application. The application is made with controllers. The application is done with all the business logic implemented in Python on the Python server. You also have all the messaging features in Odoo, like the discuss to send message from one user to another, or from a user on the website to chat with a backend operator, and so on. And of course the PDF rendering, which is done through an external tool called WK-HTML to PDF. The third layer is the data layer. It's the layer where you will have laying your data. You have a first part, which is the database. The database we are using is PostgreSQL. And you have also the file store. All the binary content of the attachment in Odoo are not stored within the database, but they are stored directly on the file system. And this kind of storage is called in the Odoo world as the file store. In the file store, you will also find the sessions. When you log in an Odoo instance, Odoo creates a session. This session is saved as a file on the file system. It's important for the next step of the deployment we will see later on. It's important to notice that Odoo is a multi-tenant application server. That means to serve the application for 2 different customers with 2 different databases, it's not necessary to deploy 2 different servers. If both customers are using the same code base, you can just deploy only one server and achieve serving data and content and for the 2 different customers, and one customer will not see the information from the other customer because they are lying in different databases. My best advice here is, whichever you see here in the slides, you have to keep it stupid and simple. Whichever the system you will deploy, the system will fail. You will face issues, and the system will not fail on the Monday morning when you are at 9 a.m. in the office. No. The system will fail when you are on a flight to your honeymoon or whatever, but not available with any kind of connection of any. So keep it stupid and simple. There is Scott Adams is the author of the Dilbert comics, if you know it. So don't create problems you don't have. Okay? That said, when we deploy Odoo, we will talk about workers. What is a worker? If you install Odoo on your machine and you just start Odoo, you will start Odoo in a mode called multi-threaded mode. This will work on every OS. It's the default way of running Odoo. It's very easy for development, but sadly, it only uses one CPU at a time. So you can have the biggest server of the world. If you launch it this way, it will only use one server at a time. And this is due to the Python jail. It's not a limitation from the Odoo side, it's a limitation on how Python is designed for executing multiple threads. Sorry. If you run this way, nothing is checking that threads are live or not. So if you launch the server this way and you launch a cron thread, if the cron thread dies for whichever reason, nothing will restart the cron. To launch the server this way, you only have one option, which is the HTTP port. So you will launch Odoo bin, HTTP port, and the default port is over there. Then this will start Odoo. You can connect using your web browser to this, your local IP and this port, and this will work out of the box. We want to use more than one CPU because your machine probably owns more than one CPU. To use more than one CPU, you will need to use the workers. Workers are not threads, they are processes. Because of the way the processes are launched, it's not possible to run this workers on a Windows machine. So for production, it's not possible to deploy Odoo on a Windows machine. You should deploy on a POSIX machine, and generally speaking, we only see deployments on Linux, mainly on Linux, some on BSD and so on. Each worker can use up to one CPU because we are not using threads anymore, we are using process. Processes are separated, they are not facing the jail, so you can use all the CPUs of the machine. There is the main process which controls if all the processes are alive or not. That means if your cron process die, the system will relaunch the cron process. When you launch Odoo in this mode, Odoo will not use only one port but two ports. It will also use a second port for the WebSocket. The option is called G1 port. Because Odoo is using two different ports, one for the HTTP request, the other one for the WebSocket request, it's mandatory to deploy a web server in front of it. Because your web browser will only connect to one TCP port. As the web browser connects to only one TCP port, it's mandatory to have a web server to route the calls to the HTTP port or to the WebSocket port. Okay? Then you have two options, the HTTP port and the G1 port. You can specify the number of workers you are launching, and you can as well choose the number of cron threads you will launch. This is the only recommended way to deploy a production. The multi-thread is not for production. The second one is the one for production. It's also possible to dedicate a process to the crons. So we will use a machine for the HTTP request and another one for the crons. To do this, we will start Odoo for the crons without any worker of any kind and just with cron processes. There is two options to do this. Either you specify workers equals -1. It's -1, not 0. If it's 0, you are back to the multi-thread mode. So it's -1, and you specify the number of cron threads. The option is called cron threads, even if it's processes. So it's not the best naming of an option, but here it is. The other option is to launch with the minus minus no HTTP options. Minus minus no HTTP options means do not launch HTTP workers for your server. When times come to growth, should you buy a bigger server or should you buy multiple servers? If you deploy on one server, you have on your server the HTTP workers, the cron workers, the WebSocket, HTML to PDF, PostgreSQL, and the file store. That's all you have on one server to deploy Odoo. If you deploy Odoo on multiple servers, you'll have to deploy load balancing. You will have to deploy HTTP worker on each of the front ends. You'll have to dedicate a big PostgreSQL behind this. You'll have to share the file store and between all the servers. You also have to share the code between all the servers. Now, the question is it better the first option with a beefy server or smaller server? The answer is, it doesn't matter. We have performed the load testing on various configurations. Each server have the same size. A front-end server, have the size of 20% of the biggest of the beefy server. As you can see, each time you add a server, you add around 20% of performance of the main server. So achieving 40 workers with one beefy server or achieving the same deployment with small server is equivalent. The thing is, the Odoo performance have a one-to-one relationship with the frequency of the CPU of the machines you are using. If you want to improve the speed of Odoo, you can just simply improve the speed of the CPU. That's a way to improve the speed of your Odoo deployment. It's not the best way, but it's not the cheapest one neither, but it's possible. So, deploying one big or multiple small server doesn't matter. You do whatever you want, it works. Given the fact that the network latency between the PostgreSQL server and the front-end server is small enough. I will describe the various situations in which you can deploy Odoo. We saw this in the first slide with, it's the simplest one, the multi-thread architecture. So out of the box, this is how Odoo is working. So I've downloaded the installer, put it on a server, and started the process. Here is what you get. But we saw that it's not the recommended way. So we need to deploy Odoo to achieve the configuration with workers. So we start Odoo with workers. On this machine we have the web server, the HTTP worker, the cron worker, the WebSocket worker, PostgreSQL, as well as the file store. That's what we have. For PostgreSQL we need high-speed disks and plenty of memory to store all databases in memory, while for Odoo, we need faster CPUs. The faster the better for Odoo. So one thing we can do is split Odoo and PostgreSQL on two different machines. So we can split PostgreSQL and the file store on a machine, and on the first machine only let the web server, the HTTP worker, the cron worker, and a WebSocket worker. You should have a network latency low enough between the two machines. Once we have achieved that, we can achieve a replication between a PostgreSQL and another PostgreSQL. That way, if my PostgreSQL machine is broken, I have another machine handily available to handle the load, the database, the file store, the sessions, and so on. On the Odoo side, you have nothing stored mainly. You just have the source code. So you can just take an image of the machine, restore the image on another machine, and you have your up and running Odoo. So nothing is saved. On the Odoo machine, everything is saved here on the data layer, the PostgreSQL and the file store. Another improvement we can do is split between Odoo and the crons. We can put the crons on their own machine. So we'll deploy the cron on their own machine and let only Odoo live with the HTTP workers, the WebSocket worker, and the web server on its own. If I'm using multiple machines to run Odoo code, I must ensure that each machine is running the same version of the code. And by same version of the code, I mean the same timestamp on each file. I said that the Odoo server sent to the web client the JavaScript, the CSS, and so on. The JavaScript, the CSS are bundled together in assets. To ensure that we have the correct assets version, we compute a hash of the assets. How is the hash of those assets computed? We pick the list of the files going in an assets. We pick the timestamp of the last modification of those files. We pick that together and compute a hash. That means if you have a different timestamp on two machines, the hash will be different. If the hash is different, both machines will compute different assets and they will delete the asset of the other machine. So this will lead you to a situation where you have empty assets. You have no more CSS, no more JavaScript. We should avoid that. To avoid that, we put the source code identical in each machine. We had to share the file store to the web server using whichever technology you want. One of the technology you can use is NFS. NFS is quite easy to deploy and handily available in the Linux machine. So as you already have shared the file store, you just have to also share the source code folder and mount the source code folder in the Odoo server. So now we have achieved a situation where we have our Odoo server, our cron server, and a replicated PostgreSQL. If I put a load balancer in front of that, the load balancer will be able to receive all the HTTP requests and send them to the web server of the Odoo server. Once you have deployed this load balancer, you just have to duplicate the Odoo box. I said earlier, the Odoo box doesn't have anything stored in it. If it was failing, you just have to pick an image of the machine and restart it. Basically, to achieve a load balanced deployment, you just have to duplicate the machine. So here we have achieved a load balanced deployment. We have a load balancer connected to multiple Odoo front ends. Those front ends are connected to a PostgreSQL server. One and only one Postgres server. The other one is doing nothing. The other one is just replicating the first one. No request can be sent to the other one. I know Tony said we are working on a way to use a replicated PostgreSQL as a read-only database server. It's still not available today. So you can only use the second machine as a failback. It's not because you have replicated your PostgreSQL that you should neglect backups. A replicated PostgreSQL is not a backup. You delete a record on the first PostgreSQL server, the record is also deleted on the second server, right? So if you need to restore your record, you need to restore a backup, to retrieve it from a backup. If you only have a replicated PostgreSQL, you don't have any backup of any kind. To manage the backup, you have two metrics, the recovery point objective and the recovery time. The difference between the two is the recovery point is the point in time where you can retrieve the backup. If you take a backup every 24 hours, and if the system falls back after 23 hours after the last backup, you can only go as a recovery point objective 23 hours earlier. The recovery time objective is the time needed to restore the system after a crash. It's not necessarily easy to lower those two metrics at the same time. Because to achieve a recovery point objective as lower as possible, you have to create backup strategies that are more harder to put in place, and then the recovery time objective will grow a bit. It's not possible to achieve a situation where your recovery time objective is 2 minutes, I can only lose 2 minutes of data, and a recovery time objective of 1 minute. I will be up and running 1 minute after a crash. No, it's not possible. You can't achieve both of them. On the PostgreSQL side, you have plenty of tools to achieve the backups. You have tools like Barman. Barman is a well-known tool in the PostgreSQL world to achieve backups, and you achieve backups in many ways. Odoo is built on Python. Odoo is built on Python, and we do not write everything out of the box from nothing. We rely on Python libraries. Those Python libraries needs to be installed to have your Odoo up and running. You have two ways to deploy the Python libraries on a Linux server. You have pip, which is the Python tool to install libraries, or you have the apt. apt is from the Debian flavor Linux distribution. You have the equivalent tool on every flavor Linux distribution. The apt is relying on the system packages. The package is packaged by your distribution. It's better to use the apt way rather than the pip way. Why is it better to use the apt rather than the pip way? Because Python libraries are relying on C libraries. And on your Linux box, some unattended upgrades can upgrade the C libraries of your system. If you install your Python libraries relying on C libraries with pip, your system is not aware of that. So you have the C library, and on top of that you have the Python library. An unattended upgrade will upgrade your system library. Maybe your Python library is completely out of date regarding this C library. So the unattended upgrade have broken your deployment. If you had used the package installation. When the initended upgrade will upgrade the C library, it will also upgrade the Python library based, which depends on the C library. So using the APT way is way more safer to achieve. If you look at the pip command, you have to add as an argument broke system packages as an argument. It's quite obvious what this command will do. So where can you find the libraries? Odoo is packaged as a Debian file. So you can go in the source code of Odoo, you will find the recipe of building the Debian package, and in the recipe of the Debian package you have all the dependencies of this Debian package. This is the location of the recipe of building the Debian package. I will be verbose for this part. Don't be afraid with the configurations. Everything is comes from the documentation. odoo.com/documentation, you have all the part of the configuration. You don't have to type in everything. I said, in front of Odoo, when you use workers, it's mandatory to use a web server. This web server needs to be configured. If you're running a multi-threaded Odoo, this is the configuration of the web server. Mainly it's listening on the SSL port and send a request back to an Odoo backend. That's what this configuration do. Once we start using SSL, we want to ensure that every user will ever come to HTTPS and redirect all HTTP requests to HTTPS and ensure that the user will always come using HTTPS. That's what this piece of configuration is doing. Now we will use the multi-workers version of Odoo. To use the multi-workers of Odoo, I said that Odoo is using two different TCP ports. So we create two backends, one for the WebSocket, the other one for the HTTP servers. And we will use two different redirection rules, one for / and the other one for WebSocket. That way the WebSocket will be sent to the WebSocket worker and the other request will be sent to the HTTP worker. That's what this configuration is doing. To do that, here it's an Nginx configuration file. Nginx will add headers to the request he sent to Odoo. We should tell Odoo to listen to those added headers. You should add the proxy mode parameter to Odoo when launching Odoo when you are deploying a web server in front of your Odoo. There was a little change between version 15 and the version 16 and upper. Up to version 15 we were using long polling. Since version 16 we are using WebSockets. There is a small header to add when you are using 16 and upper, because we are using WebSockets and not anymore long polling. So if you add recipe for deploying Odoo 15, you have to update it a bit for the version 16 and upper. And finally, it's also possible to have Nginx serve the static files, to have Odoo not serving the static files. We must ensure that it's still secure. A user cannot access attachments of an invoice he do not have access to, so it's a bit tricky because Odoo have to check this before asking the web server to send the binary content. So here is the final configuration of your Odoo. You can copy paste all of this from the odoo.com/documentation webpage. So I copy pasted everything from the documentation. When times come to connect your Odoo to your database, there are multiple options you can use. The obvious ones are the one to connect to the database, the user, the password, the host name, etc. You have an SSL mode. SSL mode means, will we use a secure connection between Odoo and PostgreSQL? By default, Odoo will try to connect to PostgreSQL using a secure connection. If it doesn't work, it will retry with a plain text connection. You will also specify the number of connections each worker will open to the database behind. Each worker in Odoo will perform SQL queries. Those queries need a connection. It's costly to open a connection to PostgreSQL, and to avoid connecting to the database each time you have a request, the system will maintain a pool of connections. The dbMaxCon parameter is the size of the pool for each worker. There were an issue in previous versions. The long polling or the WebSocket is also using this pool size. So in this version, we have split it into the pool size for the HTTP workers and the pool size for the WebSocket. The first one is called dbMaxCon and the other one is called db. I said earlier that Odoo is multi-tenant. You can have only one Odoo server serving two different databases. You probably don't want your user to have to select the database he wants to connect to. Based on his URL, you want to automatically connect to the correct database. There are two magical values for the db filter parameter, which are %d, %h. %e is the fully qualified domain name of the machine, and %d is the first name in the fully qualified domain name. You can also specify ---- database to specify the database you want to connect to by default. So in version 17, we have splitted the MaxCon and the MaxCon given. So that the connection pool size between Odoo and your database server. This permits to compute the max connection number on your PostgreSQL side. Two options still related to the database. ---- no database list. By default, there is a controller which permits to take backup, duplicate, and create databases. You probably don't want this on your production, and it's required to remove this from production. So the option to remove the web page to create or delete databases is called no database list. For European languages, when you search, you want to search without accent, there is an option called an accent, which will remove the accent when searching within the database. I said that sessions are files stored on the disk. There is a mechanism in Odoo which is responsible of cleaning those sessions. You can tune it with a config parameter. The config parameter is called sessions.max inactivity seconds. By default, it's 7 days a week. and it's a cron-based cleaning. It's a cron-based cleaning. That means you need a cron worker to clean them. If you want to log everyone out of your Odoo instance, you simply have to remove all the files in the session store, and everybody is logged out. When times come to install your database server, you have again multiple recipes to achieve this. Either you use the stock PostgreSQL database server supplied with your distribution, or you can use also apt.postgresql.org. The difference between the two is when you have the latest LTS Ubuntu, you can use either PostgreSQL 14, which is supplied with the latest LTS, or PostgreSQL 15. To make the connection to your PostgreSQL server possible from remote database server, you have two things to configure. The postgres.conf, you have to listen to the private network between your PostgreSQL and Odoo servers on a given port. You will also specify the maximum number of connections to your server. And in PGH, if you only do this, it will still not work. You also have to go to pghba.conf to configure the database and ask the database server to permit connections from the IP range of the Odoo servers. You will need PostgreSQL users for Odoo to connect to the database. This user is not a super user. It's very important. This user is not a super user. A super user in PostgreSQL can read all the file system and can execute any program on the system with the Postgres Unix account. That means he can read all your file system, like the etc password or stuff like that, all your configuration, your SSH keys, and so on. To disable this, to make this impossible, you simply have to not make the PostgreSQL user a super user. It's quite easy to achieve. So it's not a super user. And to permit the connection, I'm not using the host syntax. I'm using the host SSL syntax, which means it's mandatory to use a ciphered connection between Odoo and PostgreSQL. PostgreSQL works out of the box. But if you tune it, it works better. If you don't know how to tune it, you can read the documentation and apply all the rules in the documentation. Or you will use an automated tool which will apply all those rules for you. There is a tool called pgtune, which will apply all the rules for you. It's not perfect, but it's a very good starting point. You will still need a bit of vacuum tuning, because the vacuum tuning is not done by this tool. What do you need to vacuum? A bit of explanation on how it works in PostgreSQL. We'll create a record. Each transaction in Odoo, each transaction in PostgreSQL get an ID. This ID is an integer. Each call to Odoo is within a transaction. That means each call in Odoo gets an ID of transaction and so on. So if a first worker in Odoo creates a record, here is mainly what is happening. There is two hidden columns you don't see in PostgreSQL called transaction min, transaction max. When a second worker will start, he will get another ID of connection, and the first worker will not see the second record. Why? Because The transaction ID minimum is 2, and the first worker has the transaction ID of 1. So the first worker commit his work and start a new transaction. He updates a record. When you update a record, PostgreSQL does not really update the record itself. It creates a new line with a new transaction min, and he set the first record with a transaction maximum of his own transaction. That means when you update records, you let crap in your tables. And this is necessary to clean all this. Okay? When the worker 2 will select count equal from table, it will return only 1, because the second record doesn't have the correct minimum ID of transaction. If you commit and then select, this will return 2. This is due to the ID of the transaction. We thought that you can replicate your database. You have 2 ways to achieve a replication. The first one is called streaming replication, the other one is called logical replication. A streaming replication is basically sending from one server to the other the bits changed on the disk. The other one is sending to the other server the SQL queries to execute to achieve the same result as on the main one. You have 2 kind of replication, a synchronous and an asynchronous one. The synchronous one has an impact on the performance, because when you are in synchronous replication, when you commit on the server, you commit on the slave and then on the master. And you can also replicate on different physical locations if you want to avoid having all your systems broken when the data center gets on fire or whatever. To improve the performance of the system, you have multiple things you can do. You can do table partitioning. You can do what is called database sharding, which means putting some piece of databases on different location, on different physical servers. You can even find many people ask for multi-master replication, which doesn't exist in PostgreSQL. If you search the net, you will find plenty of solutions to achieve this. I want just to remind you something. Keep it stupid and simple. When this kind of replicated system will break down, you'll have to put them up. And probably you will be on vacation or holiday, and the student you have trained for 15 minutes will have to put this back in production. So avoid too complex system. The most question we get is regarding the worker sizing. How many workers should I use for a given number of users, this kind of database? The basic rule is you can deploy on one machine a number of workers which is equal to the number of CPU multiplied by 2 plus 1. That's roughly what you can have as workers on a given machine. And one worker will handle around 6 users. But is a user equals to another? Is a technical consultant using the system 5 minutes a day to fill in this timesheet the same user as a guy in a warehouse doing picking all day long? When you achieve the deployment for systems of a bigger size, the only way to answer this question is to perform a load test on the machine. it's the only correct way we can ensure that the system is correctly sized. You have the rule, the basic rules, but it's up to you to decide if you are in a given regular use case or a more problematic use case. If you know that your customer have complex workflows, probably this rule doesn't apply and is not sufficient. Or if your customer has really simple workflows, probably this is overkill. The problem with Python process is that once a Python process gain access to memory, it doesn't release this access to the memory. So we need to ensure that the system will be recycled and release the memory. To do this, we will recycle a worker. Recycling a worker means killing the worker and launch a new one. You have two limits, the limit memory soft and the limit memory hard. The limit memory soft means when the worker reaches this limit, at the end of his job, he will be killed softly and restarted. The limit memory hard means if the worker reaches this limit, we have hit a limit, a red flag. So the process is immediately killed. The web client doesn't get his answer, and a new worker is launched. The difference between the two, the first one is for ensuring a smooth operation in the system, and the second one is ensuring your process are not eating all the CPU, all the memory. You have limits for memory, you also have limits for CPU. You have limits for CPU, which is called limit time CPU. It's a CPU time, and you have limit time real, which is a wall clock timing. So if you are doing calls to API with latency and so on, the limit time real will be higher than the limit time CPU. If you are doing complex queries, it will be counted in the limit time real and not the limit time CPUs. If you are running complex cron jobs, probably they need more time than the HTTP workers, so you have a specific limit for the crons. And finally, you can also recycle the workers based on the number of requests. By default, after 8,000 of requests, the worker is killed and a new one is launched. Those limits ensure the system is performing smooth operation, do not eat all the memory of the system, and do not eat all the CPU to answer complex queries of the users. If you have any question, there is a pad, you can type in your question.
We got a lot of questions.
Yeah.
First, how do you share a file store between different servers?
To share a file store between different servers, you have on the machine hosting the file store, you will start an NFS server, and on each node, you will use an NFS client, and with this NFS client, you will connect to the NFS server. That's the simplest way to achieve this kind of stuff. You can also achieve this with more complex solutions, but again, I advise you to stick to simple solutions and affordable and easy to deploy solutions.
Someone is asking, we have a project on Odoo SH with one worker, but the project is still running using maxcron threads set to 0. Why?
Okay. All I said here was available for an on-premise deployment. It's not available at all for the SaaS or nor for Odoo SH. A worker on-premise is a worker which can handle one request at a time. On Odoo SH, it's a different design, so it's not the same way of computing the number of workers versus the number of users. There is a rule on the Odoo SH page explaining roughly how to compute the number of workers, but you can't apply the same rules for on-premise or Odoo SH. Odoo SH is a different project. Here we were talking about deploying on on-premise.
Next question. Have you ever tried a setup with real multi-master Postgres cluster?
Not
For example, Citus, Patroni.
No, no. We at Odoo we have one use case where we are using a Postgres master with some slaves, and we are using the slave as read-only, but it's a specific use case. We do not achieve any of the Patroni, Citus, none of them. We are just Odoo expert, by the way. We deploy Odoo, we use the technology of PostgreSQL, we love the PostgreSQL technology, but we are not PostgreSQL experts.
How to test a reverse proxy configuration with regards to the WebSocket config?
How can you test the reverse proxy configuration with regards to the WebSocket config? No idea.
Next. I don't exactly understand this one.
What attributes should I consider while trading off multi-tenancy architecture, multi-company using a single Odoo engine instance versus single Odoo engine for each company? When you will achieve, so the question is, I have multiple clients, should I deploy multiple servers, one per client, or a big server handling all the clients? If you deploy one server per client, each server should be able to handle the load of each customer, of the customer he is owning. And if the customers are on different time zones, you will lose some resources of the server because you have unused resources on servers, because you have deployed servers which are not used at some time. On the other hand, if you deploy a big server for all the companies, and if you have one customer which is creating plenty of crap on your server, it will eat all the resources, and those resources will not be available for the other customers. So it's really a matter of trade-off. There is no answer, there is no good answer, and one good answer and one bad answer. It really depends on your use case. I don't have the real answer.
Next question. Odoo stores the session files on the file system. Why? And why not in the database or in RAM or something like that?
Okay. Sessions are stored in the file system because it works, first of all. If you need to store them in the database, you need to have a database to store the sessions in. When you connect to a server, if you want to store the session in the database of the session, you need to know which database you are trying to connect to. It's not that obvious. Second, having that stored on the file system means it's easy to clean, it's easy to maintain. You don't deploy complex architecture. If you try to store the session in memory, how would you like to achieve the share of the sessions between multiple servers when times come to storing sessions in memory? You will have to deploy another layer of technology to replicate the sessions between the different servers. Storing them just next the file store and sharing between the servers is easy and reliable.
Next, how do you achieve consistency between the Postgre backup and the file store backup?
Yes, good question. uh, One of the thing you can do is just take a snapshot of the file system where you have PostgreSQL and the file store, or take backup at the same time, mainly. But solutions like Barman will not handle the file store at all. Even for the replication, if you replicate in a synchronous way your PostgreSQL, you'll have also to afford more complex technology to replicate the file store and the sessions the same way. Because an AirSync every 5 minutes will not be sufficient for the sessions and so on.
A lot of people were wondering how to calculate the number of workers you need. You provided a formula before. But now someone is asking, what about the amount of workers in a containerized Odoo? Can we use 0 in production?
No, you can't use 0 in production. 0 in production means using multi-threads, only one CPU. So you'll have to launch as many containers as you have CPUs. You'll have as many long polling WebSocket workers as you have of CPUs. You'll have to load balance between all your containers. It looks like pretty overkill just to not use the workers in Odoo. It's way more easier to achieve the workers in Odoo rather than deploying containerized with workers equals 0.
And unfortunately, we are running out of time.
Thank you. I'm available if you have any more questions, so feel free to ask.